But now we have application pen testing in 2019, APIs in the cloud. Please welcome Jamie Baxter, sorry.
No.
Go on, clap.
Hi, everyone. So I'm Jamie, and thanks for coming out. And I apologize, I won't keep people from lunch too long. So I'm well aware of my responsibility as the last line in defense between you guys and lunch. So with great power comes great responsibility. So today's talk, we're going to talk about clouds. We're going to take a journey into the cloud, and specifically looking at the deployment of APIs or application programming interface, specifically REST APIs in the cloud. And we're going to see all the different cloud services that can help you do this, and also some of the pitfalls, some of the security concerns, and how some things may not work exactly like you would think it was. And then when you're doing, both as a developer and as a pen tester, the results that you might see as your clients and as your targets have migrated their backends into cloud-based infrastructures. Just for limits of time, we're going to primarily focus on AWS cloud infrastructure and services. Not to pick on them, it's just that we can only talk about so much. So first slide is, who am I? So I said, I'm Jamie. I'm an independent information security consultant. I'm probably in that 15, 20-year plus club that Dave was just mentioning. I focus on doing security assessments, so application, cloud, mobile infrastructure. And previous to that, I worked in the aerospace, also government and finance sectors. I'm primarily focused on application security, so everything to do with apps, writing apps, coding apps, making sure apps are secure. That's really my passion. That's really what I do. And also red teamer occasionally, and also CTF when there's time. So what we're going to look at today. So an initial quick backgrounder on REST APIs and how those fit into the cloud. Cloud service troubles. So this will be a first cut at how some of the cloud services may not behave as you think they will. We'll take a look at the, and then we'll start diving into individual ones. So, how information disclosures, error messages may be a lot more severe in the cloud, the different flavors of server-side request forgeries, how role switching and role escalation becomes the new lateral movement or privilege escalation in cloud-based services. And then also taking a look at EC2. And if there's some time, we might look at some more complex server-side forgery requests and then some fun with container registries and DevOps infrastructures. So first of all, let's get into some of our background. So REST API in 60 seconds. Now, a REST API is defined as a contract between the client and server. So typically, we have a client. This can be this can be a browser. This can be a mobile application. This can be another application or other backend service, and it will issue requests to our server. The request will look like any other normal HTTP request. It will have a header. It will have its method. It will have a URL and then a body or a payload. Now, the interesting thing about REST is that when people are like, hey, how do we design this API? We're like, well, we already have all these HTTP methods. Let's use them as part of our API. So informally, a get method will get information. A patch method will edit information. Delete will delete information on the server. And this allows you to sort of organize your APIs roughly around the HTTP specification. These type of things always fascinate me because when the original HTTP RFC was written, I'm sure the implementers never really saw how it would later be used to connect these dynamic mobile apps, making tons of requests, leveraging HTTP methods in a REST-like way. So we have our server, and then it makes its responses. So and again, they reuse the HTTP specification. So 200 is okay, 403 would be forbidden, and the whole other series of 500s for server error. And so they basically wrote on this to provide this well-defined contract for applications to talk to servers and servers to respond to the applications. Now, where we start to get into trouble, though, is, and we'll always get into trouble, is when we start talking about authentications and sessions. Because there has to be a way of ensuring that the request that's made is made by someone who's authorized, and that person has the authority to do that request, and you don't allow the wrong people to do them, and you don't allow someone to pretend to be somebody else. So you typically have unauthenticated requests, which is your normal HTTP requests, but when you start to get to authenticated ones, then you have to have a way of tracking who is doing it. And there's tons of different ways of doing it. Like people will try to use tokens. People will try to use like the original one is like basic auth in the header. There's cookies. There's tokens, and specifically, and we'll talk about this in a sec, is getting into how different apps will use bearer tokens or specifically JWT tokens. So, but overall, our requests will be lumped into these sort of buckets: unauthenticated, unauthenticated, and then authenticated. It can be any authenticated user, bound to a particular user, or administrative level access. And you'll see why these subtle distinctions are important, because they map to a lot of flaws that keep coming up over and over and over again. Specifically, when servers check the requests, so often what they'll do is they'll just check to see if there's a valid token, but they won't necessarily check that the token is tied to the specific user that is requesting that piece of data. Or you will see a case where they'll just say, or they'll allow any user to edit something that doesn't belong to that particular user. And we'll see some examples. So the more things change. So back in the old days, we dealt with like large monolithic applications. The servers had constant care and feeding. They were difficult to scale, and difficult to provide mobile versions. And it was a largely homegrown code base. Now, as we moved into using cloud-based infrastructure, we use a lot more building blocks. We have these single-page applications that try to completely decompose the front end, and then we try to completely decompose the back end into a series of, we've moved from REST API, like individual servers, like running on like EC2 or VPS, and then we move now to Lambda with serverless infrastructure, and we'll see more examples. And these servers are ephemeral, meaning that they get stood up, they get stood down. The lifespan can be measured in hours or minutes, as opposed to months and years, as in the past. And it's designed to scale from the core of it. So let's take a look at these building blocks that we might assemble here. So what I've done here is, so this is just a fictitious AWS deployment for a back end of an application. So what we do here is so here would be the CloudFront entry where the request would come in. We have our static content that's stored in an S3 bucket. So instead of having a server storing this, we're leveraging S3. Here we're using something called API Gateway. API Gateway, again, is another AWS service that allows you to basically handles the part of receiving requests, parsing them. It can handle some of the validations of the tokens, and then it handles the routing them to the correct processor, or the correct service that's going to handle that request. And then also we have something called Cognito in AWS. Again, that's a service that keeps showing up again and again, and that can handle identity pools and also user pools. So this can take care of, you no longer have to sort of create a user database with a sign up and manage users and deleting users. You can leverage this service to take care of all that functionality for you. And then as we move back one more level in the infrastructure, we have our Lambdas, or choose the buzzword of the day, whether you want to call it serverless or compute in Azure, it would be compute instances. And so typically these are smaller functions that are designed to handle one or two very specific things. There's different sort of architectures that you see, different sort of factoring approaches, but in general, you want to keep them limited to a certain subset of functions. And so basically, this is our let's say our REST API, and then we've gotten it so that you have we've decomposed it into 3 sort of primary lambdas. So registration functions got associated with one, profiles got associated with another, and messages get associated with another. Now, I've seen architectures, I've seen clients where they'll do like one serverless, one sort of Lambda function for each REST function, or I've seen ones that will have just one Lambda function for all of them, or sort of in the middle. This is an example of an in-the-middle approach where you're clumping a few like highly correlated functions to the same compute instance. All right, so why are we doing this? Well, like I said, these cloud services will sort of offload a lot of the work that we do in a repeatable way. So here, for instance, this is how. So instead of trying to stand up a server, configure it, configure your front end, configure your back end, like do all the Apache configuration, do all the PHP configuration, all that good stuff. Instead, here, what we can do is say, okay, this is our API gateway. API gateway, use user Cognito pools for use Cognito user pools for user registration, deletion, sign up, all that. So basically what this does is this takes a huge amount of work off your front of your development, because now you have these little Lego pieces that you can place in. So this is great. And if it works as expected, then what's the problem, right? I mean, in theory, you should never have a pen test where there's issues with user registration and user pools. Unfortunately, as we'll see, that's not quite always the case. And the other neat thing about this is that instead of your configurations becoming tons of different files and like configuration parameters they have to script out to configure, essentially your infrastructure can be represented entirely by JSON. So, and that moves you towards the, where people say software as infrastructure and things like that. It's really no more complicated than YAML files and JSON files. But this just kind of gives you a view of what it looks like in actuality. So let's say we're doing the API programming. Well, here, for instance, we're showing the programming the profile get current user. So we're telling it that it consumes a JSON, it produces a text HTML, and it's going to respond with a 200, and the content type will be string. So we're still relying on the development team or the programmers to provide this functionality, but at least at the front end, on the gateway, the whole interface is already specified, and in theory should behave in a deterministic way. So instead of having to write out all these function handlings and URL handlers and parameter handlers, you can just apply this JSON file to the API gateway, and off you go. Now, the problem is we still are left with how do we handle authentication? And again, authentication comes back over and over again in ensuring the right people are making the right requests to the right things. All of the Amazon infrastructure relies on, you can force it to use different ones, but the one you really want to use is an OAuth 2 mechanism. It's primarily based on identity providers. We can use the user pool as an identity provider, or you can use a third-party identity provider like Google. So for instance, when you see sign in with Facebook, what it's doing is it's doing the OAuth 2 flow where it reaches out, checks your credentials against it, then it creates a token and sends it back and says, hey, yeah, this is the person that they say they are, and this is a token with whatever claims I agree with. So the idea is that you have this validation of the ID, that you have access, and also there's something called a refresh token to allow you to reinitiate a session without running through the entire authentication flow. So for instance, with a refresh token, if you have an app and you haven't used it in a couple days, and then you go in and it seems to take a little longer to start up, but it still works, you don't have to put your username and password in again, that's leveraging the refresh token. If it's using an OAuth flow, and the refresh token basically says, hey, hey, I'm back. I know the other tokens have expired, but refresh is usually good for 30 days. So, give me a new ID token and an access token. The entire way these tools work, like API Gateway, and then the Lambda authorizers all revolve around the use of tokens. And that's the same with any OAuth 2 flow. Is the validity of the ID tokens that they're from a trusted identity provider, and that they and the validity of the access token, which says, hey, you have the access to perform that request. Where things start to get a little murky is its developers and even Amazon and other providers become slightly inconsistent with the way they handle ID tokens, access tokens, and refresh tokens. Sometimes the ID token is invalid, but the access token is valid, so they still allow it. Sometimes you'll invalidate the ID token, but the refresh token will still be accepted. And we'll see some of these cases very shortly. And then finally, just the representation of all this. So it's all represented as JSON Web Tokens. They're secure in transit. They must be secure in transit and storage. They must be signed. You can encrypt them, but typically it doesn't offer huge value as long as you're not putting sensitive information in their claims. As a little aside, when you're writing your own infrastructure and assigning your own JWT tokens, don't put sensitive information in the claims. And that could include, for instance, like personal data identifiers, the plain text passwords themselves. In general, you want to avoid that. And so our typical Auth 2 flow, we've got our Cognito backend. The authentication is performed against the user pool. Again, rolling your own IAM should be the last option. You receive the claim back, and then the API gateway will control access to your APIs. Now, what does the token look like? Well, that's sort of your typical token that you can kind of see, but you typically have a header, a payload, and then the signature. The key in all of this really is the signature, because in the past there's been different attacks against token where if you set your algorithm to none and then don't sign it, it will still be accepted. Any modern library should prevent that. The one that we saw most recently was that if you had sent the algorithm instead of an HMAC, if you had set it to an RSA validation, it would actually accept tokens that were signed by the public key of the server. So that's obviously a no-no too, right? And ideally, especially with Amazon, you're not going to see any of these issues. So what did we look at? REST APIs, cloud services, user pools, IAM, IA gateway, authentication. We're good to go. So, like, life is good, right? I mean, all these challenges of sign up, validating tokens, enforcing API access, token expiry, it's all taken care of from our help with the cloud. The problem is the future isn't quite as rosy as we might like. So we can rely on the cloud services to help us manage sign up and login. They can certainly validate the tokens for us. The problem is when we get into enforcing API access. Do the services link the tokens to valid user sessions? So do they permit Bob? Will it allow Bob to make a request to Alice's data? Well, unless the programmers have specifically addressed that lateral privilege escalation or lateral data access, it won't. And this is something developers still have to take care of. And this is a common finding over and over again, and so common they gave it a name, IDOR. And the other thing too is token revocation or sign out. So whereas in the previous case, it's well understood that, hey, it's up to developers to make sure that you're managing your permission model. The token revocation is a service provided by like AWS Cloud Services. For instance, Global Signout API allows individual users to sign themselves out from all devices. Hey, that's great. But then if you dig down through the documentation, well, actually, Global Signout revokes all tokens but the ID token. And the ID token is a bearer token that is generally used with services outside of user pools. So that's a direct quote from the documentation, but that's kind of a little ominous, right? Because the ID token is what the developers are going to use to validate if the request can be made to that particular user's data. And And then if you dig down even farther, you see API Gateway does not reject it even after it has been revoked. So if you're using AWS Gateway and you have it connected to a Cognito user pool and you log out, that logout session is still valid for 60 minutes. And the API Gateway won't even check the ID token. So they only invalidate the access token and the refresh token, but you can happily continue to do requests. And this is a finding that keeps coming up again, where the development team will be like, "No, we're following OAuth's guidelines. We're doing session management properly. We have sign out. We have a sign out function enabled. Our sessions are being expired properly." And then as a tester, you're like, "Well, no, on my test, I'm still able to use these tokens long after. What's going on?" And as you dig in, you find out that no, it's because that it's just simply not invalidating the tokens. And straight from the issue tracker from February 17 is somebody asking, what is the purpose of a sign-out function if it does not invalidate the session token? I don't know. That wasn't answered. So 2 years later, almost 2 years later, we're still waiting for the answer. And just as an aside, halfway, just a little break. I just want to call out that, so a little Blade Runner reference there, a question lost in the issue tracker, like Tears and Rain. Just so you know that the original Blade Runner took place in November 2019. So we are basically at the time the original Blade Runner took place. So how's that for you 80s kids? I know it freaked me out. Okay, so another thing with cloud services, again, things don't quite always work the way you might expect them. So if you've been at Black Hat or all involved in the application security space, there's a big sort of research released at Black Hat this year by James Kettle from Portswigger, Albino Wax, probably one of the most amazing AppSec researchers out there. And he basically took an old attack that was first sort of talked about in theory in 2005 and basically weaponized it and really showed the implications. And now there's a whole bunch of research looking at content length and transfer type encoding. And I think that'll be talked about later. So I'm not going to go into the details of the attack. I just want to show you how the messaging has varied in the last couple months from AWS. So obviously, once this request smuggling desync attack came out, people were asking, "Hey, I'm in the cloud. Am I protected?" Well, so if you use AWS CloudFront, you have partial protection. They claim you had full protection, but then after they dug into it, they found out that it was primarily a blacklist they'd implemented. So we all know blacklists are just an invitation to find evasions. So although it allows specific header combinations, it's not a complete combination. On Twitter just yesterday, Albino Wax was saying that it only mitigates about 50% of the cases. AWS Load Balancer provides no protection. AWS Application Load Balancer provides no protection. They say it's in the roadmap, but it'll be a user configurable setting. AWS Application Gateway, which the API Gateway that we've talked about quite a bit, it's unknown. I couldn't find nor get a statement of whether it protects against this. Some preliminary testing seems to indicate that it doesn't unless you add some very specific header processing messages in your JSON, but it certainly didn't appear to be an out-of-the-box feature. And then finally, as their application gateway, they do have, in their WAF module, they do have specific rules for preventing smuggling header mismatch, as they call it. But you have to enable it, and it's still unknown whether that will be a complete mitigation. So just because you have protection doesn't necessarily mean you're protected. Now, moving right along to So we've got 10 minutes left. So moving right along to some other interesting things. So the classic finding in an API pen test on a normal on an on-prem or non-cloud-based architecture, is the information disclosure. And typically, an information disclosure might take the form of a verbose error message that sort of describes the query that failed, or gives you information about how long a request took, or any of that good stuff. And typically we dutifully put them in findings, and there's a chance if you chain enough information disclosures together, it might give you some, it might lead to something more impactful. But the problem is that with the default configuration of, say, Lambda functions, is that the default behavior with an error message is to dump the process environment variables. The problem is the process environment variables contain AWS key, AWS secret key, and session tokens. So now there's ways to prevent that if you enable certain configurations. But the problem is that that's all you really need to sort of to take over the account. And what's interesting, or at least take over that role, I should say, that's more correct. What's really interesting about cloud infrastructures is as you start using more and more cloud services and cloud infrastructure, it now all becomes about the roles and permissions that the entity making the request has, and everything has a permission. So whether it's the individual Lambda service, whether it's the API gateway, whether it's the EC2 compute in the background, it's all tied to roles. And once you get one, you can often privilege escalate or laterally move, i.e. switching roles. It's the new privilege escalation, and to achieve to get to an account that might provide more impactful, more criticality. In fact, the good folks at Rhino Security have written something called the PACU framework, which provides, at last count, I think it was 25 different privilege escalations techniques within an AWS infrastructure. And that's why you really should be considering also having cloud security assessments, where you give someone the lowest privilege role possible within the infrastructure, and then from there see if they can escalate to console control or something critical like S3 exfiltration. So server-side request forgeries, again, it's another mechanism. So basically, in a normal infrastructure, just means you can make the server request something. So you can request local resources or internal resources. The problem is that in the cloud, you can also hit the metadata instance. And this is a sort of a classical attack, is that as soon as you have an SRF vulnerability within a cloud-based, something on EC2, for instance, you can now start requesting the metadata and AWS key, secret key, session token, and then you can start doing that same sort of role shuffling and role juggling and role escalation that we just saw. And there's so many different ways to get these keys, and there's so many different metadata endpoints to hit. So these are all different sort of, if you do find an SRS vulnerability in a cloud-based service, these are all ones you want to start looking for. And the interesting thing is that now people are trying to come up with mitigations and like, how do we stop these SRFs? And so some people are trying to put in proxies. Unfortunately, others are trying to put in whitelists. And so these are just some of the common evasions that just keep popping up over and over again. Is that you can shorten IPs, and also you can rebind DNS entries. And there's a really good talk. I believe at DerbyCon that really gets into some of the DNS entry rebinding. So takeaways. There's a lot of nuances in moving your applications to the cloud. Even from moving a simple VPS to starting to leverage these cloud services. A lot of building blocks. They can really help. They can really solve a lot of problems, but they can also create new ones if you're not aware of exactly what's going on behind the scenes. The devil's in the details. All these high-level platitudes about zero trust and DevSecOps aren't going to make these apps more secure. Instead, what it really comes down to is rigorous and diligent work by technically proficient practitioners with the business support needed. And ultimately, these same problems will keep coming back unless we address this. So We have, I think, probably about 2 minutes left. So need an application pen test, need a cloud penetration test, feel free to reach out. Or if you just want to talk about clouds, or if you want to talk about how the Raptors are going to repeat this year. Thank you. Oh.
Thanks. Great talk. As far as documenting APIs, I've seen some people use Swagger to auto-document their APIs. Is that helpful, or is it much better if people don't just rely on an automated robot to do that and document it themselves?
So you always need that stage of manual check, but Swagger, like having a Swagger output, is actually extremely helpful because when I'm doing an assessment and I'm talking to a client that's based around an API assessment, one of the first questions they ask is do you have a Swagger or YAML file for your API? Because then what you can do is you can take that and it can be fed into like the OpenAI parser and Burp, and now you can have a repeatable, like at least a standard baseline that you can say, I have been through every single API call and they've all been tested with these parameters. It doesn't mean that that's where you stop. It just means that now you can have a repeatable, deterministic test of the API. So very useful. So to answer your question, very useful. I always love to get them on assessments, but you still need that second piece where you still check manually for common API methods. And ideally, if you have the source code, validate that the routes that are actually in the code match the Swagger file that you have, because one of the common things that happens is you get a Swagger file, and then like a test starts 2 weeks later, and then between that time period, the devs just fit in 1 or 2 more functions. Oh yeah, and we changed this one parameter. Oh yeah, and we did it, and we changed this header. So it can be a bit of a moving target. But to answer your question, they're great to have.
Hey, so I'm not really an application developer, so a little bit of your talk went over my head, but it was very interesting. And I'm curious about some of these issues that you highlighted seem to be more based around the services being offered by AWS, such as when you log out, it doesn't necessarily kill the session ID. Is there something you could do as an application developer to mitigate against that?
Great question. So the way you can do it is you need to keep track of every. So when someone logs out, the app would have to keep a revocation list. So it would have to keep track of every token that had logged out. And then when it receives a new request coming in, it would need to go to that revocation list and say, hey, this request that just came in, are you in the revocation? Have you been previously logged out? So the app would have to take on some more work than they might initially think. But most app developers don't do that even without cloud services. So, but the ideal situation would be that you check against this revocation list, because the alternate approach, which I've seen a few times, but really ends up consuming way too many resources, is checking every request to see if it's valid. Well, now you're just duplicating API Gateway's job, and now you're doing all kinds of extra processing on a token you don't have to do. So it's easier just to compare it against a map of invalids that you expire after an hour anyway. So if the maximum expiry time is an hour, after an hour you drop it from the revocation list anyways. No problem. Sure.
You showed.
So, okay, so I'll do the second question first. So that would you're at the end of the day, you're still trapped by the idea that you have to submit your credentials to somewhere, right? So in this case, in like an OAuth 2 flow, you're doing it against the identity provider. So in that case, it needs to be over HTTPS, but once you're in an HTTPS tunnel, and assuming you're using like a non-vulnerable algorithm and a strong key, and you're not up against Time AI or few people get that joke. You're not up against like some crazy ability to decrypt something. That's how you have to do it: is a post parameter with an HTTPS tunnel and then to it. But to your second question, for the storage of the token, that's a great question, and that is a challenge. So the token has to be stored somewhere, right? So yes, if the endpoint device is compromised, then yes, the token is now compromised, and there's really no. As far as I know, there's no way around that particular challenge. That you need to take care of your tokens and care for them and keep them safe. But at the end of the day, if someone steals the phone or someone steals the hard drive where the cache file of the browser has it, then they have your token. And to be honest, one of the things you look for in an internal assessment when you have someone's account, like you're on a box, is to see what sort of credentials are stored in local storage and browser storage, and a JWT token is always an interesting find.
And we have one last question up here.
Sure.
Yes, you mentioned some security researcher, James something.
James Kittle. James Kittle, Albino Wax.
Oh,
and he's the lead security researcher at Portswigger, and his content is always amazing.
Oh, and also the company that made the article, the 25 ways to hack AWS. That wasn't quite the name of the article. So it was a framework, and it's a framework it's a company called Rhino Security, and they create a framework called the PACU framework that specializes in AWS security. There's a DerbyCon talk on it from last year, either this year or last year, and they have a huge number of blog posts that really delve into individual privilege escalation techniques, and they've automated it into their framework. And they're working towards having a platform that will have these different AWS-specific lateral movement, and role privilege escalation techniques baked in.
All right, thank you very much.
Thank you.
A token of our appreciation.
Thank you.